Hello, this is Ms. Martin, and I am going to go through some things on homework number 4. So this is the pre-AP chapter 1 and 2 homework, and we're going to look at a couple of things from homework number 4, just in case maybe you're having some trouble setting things up. And then right after I post this video, I will also be posting a key for the homework so that you can maybe check some things so that way you can know, are you doing it correctly. Remember that when I check your homework, I will be looking for, are you showing your work? So the key is not going to have the work. The key is going to have the answers so that you can check and see how close you are, or if you're making big mistakes. But you can at least check them. So when I check your homework, I am looking for work. So let's look at homework number 4. So homework number 4 runs into, you're talking about dimensional analysis, and why this tends to be an issue is because we're looking at multi-step dimensional analysis, and that's harder because you're having to look at how to set up the problem, and so that tends to be a little bit of a challenge. And so let's look at a couple of examples here. So when I look at, for example, I'm going to start with, number 2. So we're looking at number 2. So in number 2, we're asked to go from gallons all the way to liters. And so what we want to do is we want to figure out what kind of information up here in the conversion factors we're needing. And so if we look at the fact that if we are working with gallons, we can go from gallons to quarts, and then we can go from quarts to liters. And so we're going to set up that problem. What I'm going to do is I'm going to set it up, show you how to set it up, remind you of some things, how we set up dimensional analysis problems, and then I'm going to let you calculate it. Okay, so let's set this up. So I'm going to start. So 0.0032 gallon over 1. So remember that we put gallon on the bottom. I'm going to use this first conversion factor. So it would be 1 gallon is equal to 4 quarts. And then we're going to set up the second part. So then we will have quart on the bottom. So quart goes on the bottom. And so it would be 1.06 quart. And then 1 liter goes on the top. Now, one of the things that you can do with dimensional analysis, remember, is that you can cancel out your units. So gallon should cancel gallon. Quart should cancel quart. And you're left with liters, and so that's exactly what you want. So you're going to take everything on top and multiply it together, take everything on bottom and multiply it together, and divide the two. So when you look at this, so I multiply everything on top, I'm going to get 0.0128 over the bottom, which is going to be 1.06. So then I would divide those two numbers and I would get my answer. Don't forget about significant figures. If you look at your number that you began with, so that right there tells you that your answer can only have 2 significant figures. Remember that the leading zeros are not significant, so those would not count. So your answer should only have 2 significant figures, and your unit for your answer should be in liters. Okay? Let's look at number 3. Number 3 pulls in rate. So I'm going to show you an easy way to do rate, and that way you can go ahead and look at that. I will try to show you, I'm actually going to show you 2 different ways to work with rate. You can pick which one works best for you. Some people like to do it all in one big step, and then some people like to break it up. So I'm going to show you in one big step first, and then I will show you using 2 dimensional analysis problems. So let's do this. Okay, for number 3, I'm going to start by doing this in one big step. So I'm going to focus right now I'm going to focus on this first part, which is dealing with the fact that I have miles per hour. So when I write that, I'm going to have 35 miles. Make sure you put MI on here for miles because you're going to meters per second, and that can get really confusing really fast. And instead of just putting 1 down here, I'm going to put 1 hour because it is a rate, and so I've got to have it as miles per hour. Now, like I said, in just a few minutes, I'm going to show you a different way to set it up, and you can kind of pick what works best for you. But let me show you this way first, okay? So the first thing I'm going to do is I'm going to go ahead and take care of the fact that I've got distance. So I like taking care of distance first. So I'm going to use the conversion factor that 1 mile is equal to 1.61 kilometers. Okay, and then I want to go to meters. And so I know that 1 kilometer is equal to 1,000 meters. Now that right there, that conversion factor came from my metric line. So instead of moving my decimal place over, which I could do, it just makes it a little more challenging since we've got this hours to deal with as well. I'm going to put this in here as a conversion factor instead of worrying about writing out King Henry died by drinking chocolate milk or whatever way you want to remember those. Okay, so right now if I took this and started marking things out, I would see that mile cancels mile, kilometer cancels kilometer, and I'm left with meters right here. So if I stopped right here and got my answer, I would have meters per hour. So you see those are the two things that are left. So I don't want meters per hour, I want meters per second. So I have to keep going. Now we're going to start looking at the time aspect of it. So I'm going to start, I need to go from hours to minutes to seconds. But the only thing is, I want you to look at this. Now the hour is on the bottom. So if I want to cancel that out, I have to go to the top here. So I'm going to put hour up here. And so I know that 1 hour is equal to 60 minutes. And then if I put minute up here, I know that 1 minute is equal to 60 seconds. Nope, I don't want to do that. It's just S. Sorry about that. Okay. And so now if I look at it and I try to cancel some things out, see what I have. So I know that hour cancels hour, minute cancels minute, and here I have seconds. So what I'm left with, the only things that have not been canceled out are meters and second. And so I can take and multiply everything on top, multiply everything on bottom, and divide the two, and that's going to get me meters per second. So that's one way to do it. I'm going to show you the other way to do it that's going to take it and put it into two different calculations. So that's one way. This right here is one way. Let me show you another way. Okay, so let me erase this. All this out of here. Erase, erase, erase. Some people like to do it all in one. Some people like to divide it up. Basically, if you're showing your work in dimensional analysis, then that's okay. There are some problems where I prefer to divide it up depending on how the problem is worded. Okay, so what I have to realize here is that this 35 miles per hour is actually two different things. It is 35 miles and it is 1 hour. So I'm actually going to just talk about miles, and then I'm going to do a whole separate problem down here where I'm talking about hours. So I'm going to do two problems. So let me show you how to do it this way, and then you can kind of think about what works best for you. Okay, so I'm going to deal with distance first. So 35 miles. So we're going to go from miles to kilometers. So this is 1.61 kilometers is equal to 1 mile. Okay, and then we're going to say that 1 kilometer is equal to 1,000 meters. Okay, so that's the top part. That would be looking at just getting the distance. So that's just working with distance. Now we want to work with the time. So now we're going to take the time, and I'm going to say that 1 hour, so 1 hour is equal to 60 minutes, and 1 minute is equal to 60 seconds. Again, why do I always say SEC? We want to go just to S. Sorry about that. Old habits die hard. Okay, so if I take and I start canceling things out, so let's cancel things out. So mile cancels mile, kilometer cancels kilometer. If I multiply this together, what I'm going to get is I'm going to get 56,350 meters. If I multiply this out, what I'm going to get is I'm going to get, it should be 3,600. Let's double check. 3,600. Hour, minute, seconds, so seconds. And then basically I take these two numbers and I divide them. So I would say 56,350 meters divided by 3,600 seconds, and I would get my answer in meters per second. And so that's your answer right there. So this is just another way to do it. So that's kind of your option. You can figure out what way works best for you. Okay? That is very similar to how you would do number 6. So number 6, you would have 200 yards and you have 24.8 seconds. What I would do is I would pick one of these ways that we talked about up here, and that's how I would do number 6. On number 6, your starting point, if you want just to help maybe get started, you would have 200 yards over 24.8 seconds. Now you could start it like that. Some people don't like this because it's not a 1 right here. That's kind of up to you. So some people will start it like this, where it's going to be all one long line. Or you could do it as 2 different conversions. And have 200 yards over 1, and go from yards to feet to miles. So you'd have your distance, and then you would have your time, 24.8 seconds over 1, seconds to minutes to hours, and then you divide those two numbers. So this is one possibility. There are 2 ways to work this out. So when I look at your work, that's what I'm going to be looking for. What way did you do that? Okay. The other problem that tends to be an issue is this one right here. So number 7. We're trying to introduce you to the idea of the mole, even though technically we won't do any calculations with mole until much later in the year. But it's using the idea of dimensional analysis to start looking at mole. Okay. So this is no different than anything we've done. This is no different than any other dimensional analysis problem that we've looked at. What you're using is you're using this idea right here. 1 mole of water has a mass of 18 grams. So that's your conversion factor. It's saying that 1 mole is equal to 18 grams. That's what you're using to set up your problem. So for example, in A, 7.8 moles over 1, you would put 1 mole down here and 18 grams on top. So it's just one step. You're just going from moles to grams. This is why we do dimensional analysis, so that when we get to mole, you understand the idea. When we start looking at moles and molecules and atoms, you'll understand the idea of dimensional analysis. This is not something you're used to. When we talk about time, when we talk about distance and things like that, those are things you're kind of familiar with. But this is something that you're not, and so that's why dimensional analysis becomes so important. Okay, so those are the ones that I was looking at. Those are the ones that I was trying to help you on, so that you can kind of get, maybe if you need that little bit of help to finish everything up tonight, or to work on your homework. So anyway, if you have questions, email me, let me know, or talk to me tomorrow. Talk to me in class. See you later.